Thank you for joining us today for this webinar on using VividSheets, which is one of our products here at VividCharts. And we titled this Tailored Calculations. I think you're going to see some interesting things and new features we're adding to the product, and we just wanted to highlight some of those, specifically going through some workflows and really trying to get your imagination going on some things you can do with some of these new features. So today, we have myself, I'm on the product team, and we're going to have three others with me today doing some demonstrations. We have Kevin Moore, Dylan Baker, and Clarence Adams joining me today. And we're all part of the product and engineering team here at VividCharts. So we each have a little bit of a demo to give you and show you these new features that we've been working on for this next release. Now, here are a few things that we're going to cover. First of all, if you're not familiar with VividSheets, I'm just going to do a brief introduction to what VividSheets is and why we created VividSheets almost a year ago is when we were building it and getting ready to release it. Then we're going to go into VividFunctions. It's a feature of VividSheets. And then we're going to specifically dive into specialized VividFunctions and what those are. And then we're going to demonstrate the possibilities that specialized VividFunctions allow. And the specialized VividFunction really is the new feature and capabilities that is coming out pretty soon, and that's going to allow some of these use cases to be created. Okay, so why did we create VividSheets? At VividCharts, we often talk about the process of reporting, and we use kind of this three-phase framework: data, design, and delivery. And we've always done design very well. We've had a well-known chart library, and we have, a very extensive chart library for visualizing your ServiceNow data. And last year, we started having more and more requests for, custom ways to get data created inside of ServiceNow. So using their ServiceNow data to get custom metrics, calculations, things like that. And VividSheets was the outcome of that. And what it does is it allows you to do some calculations, create some new KPIs, track those, and then use that as a data resource for VividCharts. It is a standalone product, though, so it's available in the store, as a free app, so you can go download it and look at it yourself. So VividFunctions is a part of that. And on the left-hand side here, you see what is the current out-of-the-box VividFunctions. If you go into Excel and you're using Excel or using Google Sheets, you'll see, functions that are a lot of the time that you may use. The functions that we created in the first release of VividSheets were things like counting and summing, and those allow you to send a queried or filtered set of data from ServiceNow into the sheet and then do some counts and sums around it. And then we have some basic mathematical functions. It allows you to get pretty far. And so we've seen cool things that customers have done with it. We've done some pretty interesting things with it. But we've also had customers come to us and say, hey, there's this function that I have in Excel, or I want this sheet to be smarter. I want it to be able to do some, more complicated things. And so that's where the idea of specialized VividFunctions came in. It gives you an ability to create these new functions that you may use just for your sheet that won't necessarily be in every product. And that's on the right-hand side. They now, after you add them to your product, they live down here at the bottom of that list. And so we're going to go through some of the capabilities, or just try to inspire you of possibilities that you can do with specialized VividFunctions. So I'm going to go through a couple things that we've had customers ask. They're pretty, straightforward ideas. And here is one of those that, I'm going to show today. And there's this function in Excel called network days. The idea is that you get the count of days between two dates. And then, if you're looking at like resolved times, you only get business days. You don't get every day of the week. And so, currently we see people, going to ServiceNow, exporting it, going into Excel, doing all those steps to get it. And so I'm going to show you how you could possibly do that with a specialized Vivid function. The next one is, sometimes you collect data through a query or something in ServiceNow, and then it's the next time you query it, you get updated data. But sometimes you want to freeze that value. For instance, you want to maybe freeze last month's value, and you don't want it to be impacted when you collect the next set of data. And so that's the next example I'm going to give. It's one that we hear people talk about and ask about. Again, pretty straightforward examples that I'll share with you. And then I'm going to hand it over to the other guys that have more creativity, and they're going to show you, the realm of possibility here. And I think, some use cases we have customers come to us with will be not explained directly, but they will show you possibilities that would allow you to do some of those things people are asking us for. So let's get right into the demos, because I think this is going to be the most interesting thing. I'm going to start off, so I'll go ahead and escape out of here and go over into my ServiceNow instance. So the first thing I'm going to do is, we got our incident table. I'm going to come back to this here a couple times, so just make sure I got it pulled up. This is currently, I just have it filtered into open on today. So I got 25 incidents. Okay. Here's the first one that I said. So again, Excel has a calculation called network days, allows you to get the count of business days between two dates. And there's a lot of steps to that. But what if you wanted to get that calculation and you didn't want to have to go through all those exporting, importing kind of steps? With the new function that I created called average business days, what it does is it takes the table, it takes the encoded query, just like all of our other functions do. In this case, it takes a start field and end field. So two fields on the records that I want to use to get the start and end date. And then based on that, I can, it calculates the average number of days between those two dates based on the records I fed it. So we'll look at an example here. So here I'm using I2, which is the incident table. The encoded query here is I7, which in this case is, all the records from last month. And I'm using the opened at and resolved at date. So the nice thing is, instead of doing all the import export workflow, I could come in here, I can, set up which one I want to use on the calculator I have here, and then I can go collect the function. Now, I only included two values here because it does take a few seconds to pull in the data. But then, as you can see, a few seconds is much better than, half hour or hour of, all the other workflow that you may have. Again, I have one assignment group here. So in this case, we're pulling in I10, which is the service desk. But if I wanted to get it for analysts, I could just change this formula to I11. So just an example of, building my own function, getting the calculation that I want, that I would probably have done in Excel in the past. So that's pretty straightforward, I think. Let's go into it. So what I want you to imagine is think of other functions that you may use, and your ability to recreate those here also, if you use those in your processes. So let's go to the other example I have. Okay, so I'm going to use this example. And for this, I'm just getting counts of incidents that were opened this month, this week, and today. But what if I wanted to, I wanted to get today's value of incidents open, but I didn't want these two values to change. I wanted to save these. I'm using this example because of the ability to change records in my instance and show you. But imagine that maybe you have Monday, Tuesday, Wednesday set up, and you wanted to collect that on Tuesday and Wednesday, but you didn't want Monday's data to be changed. This gives you the ability to do that by this specialized function. And I'll show you that one by going here. So this takes in the table, the query, if I want it to be the value to be static or not. And then if it is static, I need to give the cell value. So I think it'll become obvious here. And so here are those values. So in this case, these are true. So I want these to be static. Let's go ahead, change these to false. I'm going to go ahead and collect. So now it's going to go recount those values. It should be pretty straightforward. So let's go over to my incident table. I do have 25 here. So what I want to do now is, again, I'm going to add a new record, but let's say that we don't want this one to change. I'm going to hit save. And then I'm going to churn, oops, okay. I'm going to churn this one to true. Actually, let me put the values in the cell below so that we know what we got. Oops, let me recollect that really quick. 160. This is just so we can remember what we had here. Going to hit save again. And then I'm going to turn this to true so that the value becomes static. And then we have 25. Let's go back over our incident table and I'll quickly create an incident here. A couple things. Where's it? Went to the other table. So let's go incident. I'll filter this back out to today. Okay, so that incident got created. I have 26. Now, if I go to my sheet and I hit collect, I would expect this one to stay static and the other two to update. And you can see that's how it happened. So again, I froze this value so that it's not changing, even though I'm collecting new data while, this week and this month updated. So you can think of all the reasons why you may want to essentially take a snapshot or freeze data so that you have that value for the future in your charts or whatever. So I'm not going to go through the example of using these in a chart, but you can imagine how you might use that in a bar chart or a pie chart, something like that. Okay, like I said, mine were pretty straightforward and use cases that, I've talked to customers about. I want to open your mind up a little bit, and I'm going to give this over to Dylan and Clarence. So I'll stop sharing and let you guys take over for a second.
All right, let me just share my screen real quick. All right. So yeah, me and Dylan have built out something a little different. We built out a game of tic tac toe here. So right now you probably just see an empty sheet with some cells. So what we have is cells A1 through C3 is actually a tic tac toe board, and we created two functions. One function simply gets the tic tac toe value, and then another function sets that tic tac toe value. So I think the best thing to do is I'm just going to go through a turn here, and I'm going to set cell 1 to X, and I'm just going to click collect data. And what that's going to do is it's going to send this command out, and it's going to save that value to a state table that we created and complete this turn.
And Clarence, just for clarification, when you say state table, that's a ServiceNow table that this value is being added to.
Yes, so we did create our own little scoped app that basically consists of a tic-tac-toe table, and it just saves the state of all of these cells. And I think me and Dylan are just going to go through a couple turns here, and then we'll take a little peek behind the curtains and see how everything works. But yeah, this basically saves this value to a tic-tac-toe table and then returns that value. So I completed my first turn. I've set cell A1 to X. So I'm actually going to stop sharing my screen, and Dylan's going to share his screen and complete his turn.
Yep. So here I'm working from a different sheet. Also set up in A1 through C3 for my tic-tac-toe board. And first I'm just going to fetch, which we'll just grab from the table that Clarence wrote his move to. So I should see his move in A1. We see that there. Then I'll play a move back in C1. I'll write an O to that cell, collect my data, and we should see the O appear in cell C1. Sometimes it does take just a sec.
And once we're done with our turns, we'll take a peek behind the curtain and see why sometimes this turn can take a little bit.
Yep.
And if I've got the time, I might talk through how we could optimize this a little bit in the future.
All right, we did finally get the O here. All right, and then everything's updated. Then I'll kick it back to Clarence and he should be able to run the fetch again, and he'll now see my move that I just made.
All right, so I'm just going to switch my cell and value here to fetch. And this is going to fetch Dylan's latest turn. All right, so I see he has an O and C, so I'm going to do a quick turn. I'm going to set B2 to X, which probably should have been my first turn. That's always the best tic-tac-toe opener. Okay, so I think we are going to stop the game there to save myself some embarrassment because Dylan beats me every time. And I'm just going to take some time to kind of walk through how we built this out and kind of what it does in the back end. So I think the first thing we should go through is probably the table that we created. I'm just going to refresh this real quick. So it's a very simple table. It's basically a collection of cells and their values and whether they're currently updating. So not too much to look at here. Cells are just references to VividSheet cells, and X's or O's and whether they're updating. Where it gets interesting is the relationship between set tic-tac-toe cell and get tic-tac-toe cell. So this specialized function here actually lives in this status cell, and it has a couple variables. It has cell and value, which I have referenced in A6 and B6 here. And this allows us to do a couple things. We have some commands set up here. So I'll actually run the reset command real quick, and we'll go through that. So whenever I first started sharing my screen, this is kind of the default state that I have my board set up to as the reset command. And we'll have to bounce around between the two functions to get full context. But if we have a value of reset, essentially what happens is this function will query our tic-tac-toe cell state table, and it's just going to clear everything out and set updating to its default state of true. And all that's going to do is let this get tic-tac-toe cell get that empty cell value. The next command that we have that me and Dylan used a couple times is fetch. And all that does is set our cell value to board fetched to let us know that we're just fetching a value. But get tic-tac-toe cells where all the work happens. So here we have an if statement saying if the cell is the current updated cell, we're actually going to do a lot of work to get that value, and we'll go over that here in a little bit. Otherwise, we're just going to get the current state of that cell. So that one's pretty simple. This is where it gets fun. So the main workflow here is our set function here actually identifies which cell that we want to set our value to, and then updates that to X or O. And then once that write function is complete, or that write operation is done, it's just going to set cell value to updated cell to whatever value we see. So if I update a cell here, you'll see A1 has been set to X. So that table here will get updated. And we'll also set updating to false once we're done writing to the cell. And we'll go over why that's important here. So these functions are asynchronous, and they have no context with each other. So get tic-tac-toe cell doesn't just know when this set function is done running. So if it's not the cell that we're currently updating, so if I'm trying to set cell A1 to X and this function is running in B1, it's just going to grab the value. But if this cell is A1, what it's going to do is it's going to query that cell state table for the current cell, and it's going to see if updating is set to false. If updating is set to false, we're going to set updating to false here unless the cell value is the same value as before. And then we're just going to set updating to true so that we continue to loop and check. So essentially here we're just checking over and over and over, is that write function complete? Once we get all of the right values that says, hey, that write function is complete and we're good to grab this value and return it back to the board, we're just going to return cell value here. And we're going to set cell value to what that value is and break out of this loop. So yeah, that's why it takes a while sometimes for the turns to go through, because we have to loop over and over and wait for that write value to be complete. One important thing to note here is we do have a max seconds variable set here. So what this does, this is a maximum time that this function should try to run. And what it does is it just creates a new glide date time object. And every time that it loops, we're going to see if we've gone over those max seconds. And if we do, we're just going to return the value that this cell should be. That way the database can just write that value and we can continue on with our game. So yeah, I know that was a lot. Another important part here that we do is once we're all done with all of our operations, we set updating to true as the default state so that we can continue to read that updating field as we continue to try to read values and all that good stuff. So that was a lot. I'd also like to talk about some of the improvements we could have made to this game. We have one table that just records cell states, and this is totally possible with specialized functions as well. We could have also created another table that was just user states so that we could tell when or who the last player was to have a turn. And we could query that table for every time someone makes a turn and make sure it's actually their turn. And that would also enable us to have like a winning state. So once we query and we see that we have 3 X's in a row or 3 O's in a row, we could add a little message here that basically just says Dylan or Clarence won, either or. And I think that would also make that we could also add some more optimizations to this with that as well. because if it's your turn, then we know who has made the actual update and all that good stuff. So yeah, that's Tic Tac Toe and VividSheets.
So Clarence, I think it's important, maybe to answer or ask some of the so what questions. And so maybe I'll prompt you and Dylan with a couple of those.
Yeah.
I think one key characteristic here, at least in my mind, is that is this 3 sheets or is this 2 sheets? Like one thing to see here is that these sheets are essentially talking to each other through this function, the way I have this set up.
Yeah, so this is 2 sheets. So we have my sheet here that we're looking at, and then Dylan has his own sheet that he's playing off of. And yeah, you're right. These sheets are essentially communicating with each other. So that's something that wasn't necessarily possible before specialized functions. But yeah, we are actually communicating with each other, writing to tables, reading from tables. It's all very specialized.
Yeah. No, I think that's important to call out, especially the intermediate, I guess, talking point between these two is that ServiceNow table you created.
Yeah, and that's one really cool thing is that these tables both have kind of a shared state. So yeah, to be honest, when we were originally trying to build out tic-tac-toe with specialized functions, we kind of avoided creating a centralized state table like this, and we were just going to send values back and forth to each other. But we ran into all sorts of issues with that. But this is really nice because there is a central source of truth here that both tables can read from, which is super helpful for like calculating the actual state of the game. So both players, as long as they run that fetch command, they both have the same exact state.
Yeah, I think it's also critical is like people are trying to imagine their own use cases. I think this proves, customers have asked, and people have asked us about VividSheets specifically. Currently, before specialized functions, it was a pull data from ServiceNow capability, and people often asked, can I also write back to the tables? And you can, like, VividSheets has a pretty good API with it, and so it gives you the capability of doing some stuff. But I think with specialized functions, you proved through this game, it's definitely possible and can become quite easy once you have a specialized function set up for that purpose.
Yeah, and that's another good point too. So, it's easy to forget that because we're just messing around with X's and O's here. But one really cool thing that you could do with like a table that's not just recording tic-tac-toe cell states that you couldn't do before is our functions before grabbed aggregate data and let you sum and minus and divide and all that good stuff. But this actually allows you to fetch values from a record on a table. So you can fetch the actual value of a record, not just aggregate data. And then you can also write values to records as well to other tables, which is super important. And that's another ask we've gotten from a lot of our customers is, can we read values from a table? And then depending on what values we get back, can we write a certain value to another table? So you can imagine you could have a specialized function here that reads a certain value from a certain table, and then your specialized function could have some logic that says, hey, if this value is this, write this. Or if this value is this, write this different value to this table.
Yeah. Yeah, I guess you guys did what I was hoping to do. My mind's going pretty wild with all the possibilities. You can start thinking of all the possibilities here.
Yeah, that's one thing we ran into as well when we started building this. The possibilities are like the different ways we could have built this with specialized functions. There's a lot. Like there's not much holding you back. It's really cool.
Cool. So Any last comments from you and Dylan before we head on to our next demo?
None for me.
I don't
I think
believe.
the only thing I want to say is this was honestly really fun to build out in VividSheets, and honestly, I might just continue to improve on this as I get free time and see how far we can take this tic-tac-toe game.
Cool. We'll share a video of it with everyone on YouTube or something with the improvements. Okay, so let's go into, I think, another exciting demo. Kevin, you want to go ahead and share your screen and kick off your demo?
Yeah, absolutely. So given that at the time of this recording, it is winter in Kentucky, and the one thing that gets us through winter in Kentucky is basketball, I wanted to play with that idea a little bit for my sheet. And so what you're seeing right now is a sheet that I consider in progress. And before I dive into what is here, I want to walk you through the data of the data behind these cells. And so I built, like Clarence and Dylan, a small scoped application. It includes 2 tables. You can kind of see the breakdown here, but the primary table is just a table of teams. Those team records just have a field for the team name. The secondary table is a table for games. Those include references to teams for these fields, Team A and Team B. They include a week field, and then optionally a winner, which is again a reference back to teams, a winner score, and a loser score. And so the sheet you're looking at now is based on that data, and it kind of represents an SEC conference season in progress. And it's kind of abbreviated. We only have 8 teams. It's kind of unrealistic because Vandy is 3-0, but you'll have to bear with me here for a second. And so this section up here at the top left represents just the conference standings. And so if I click on this top cell, you'll see that this is a specialized function I wrote called team standing. It consumes the place of 1 through 8 and returns the name of the team that's in that position. This specialized function then in column C consumes the value of column B and returns that team's current record. Then over here, this kind of right side is meant to be a focus on an individual team. And so, cell E2 here is just a reference to an arbitrary team from this list. Column F rather consumes, this value in E2 and gives that team's current record once again. And then also these cells return points per game and points allowed per game, some basic stats. Down here below that, we have a schedule of the team, including which games they have won and lost, and then the scores from those games. And so, the opponent row rather consumes a reference to cell E2 up here, and then also whatever this week is, and returns the name of the opponent. Below that, we have a similar specialized function that also consumes the highlighted team in the week and gives the result of whether or not that team won or lost, or if that game has not been played, just returns an empty value. And then finally, we have the score of whatever this game was. So that's all cool. That's all well and good. But I think the value of this sheet and its potential is to forecast what the record of a given team could be, or the most likely outcome of a season for a given team based on, their current record, their stats, and the stats of their remaining opponents. And so I'm going to build that function live here on this call. But I guess before I dive into that, any questions or thoughts about any of this data we're already looking at? No?
I don't see any questions. I think you're good to go.
Great. Okay, so let's start building this new specialized function. So I'm going to, here in my history, pop open the specialized function list, and I'm going to hit new. I'm going to call this specialized function team projected record. For my example, which you can see when you select one of these specialized functions, you get this example text. I'm going to say team projected record. This is going to end up consuming 2 arguments, team name, and then the record to check. Because we know that this specialized function is going to be used, 1, 2, 3, 4, 5, 6, 7, 8 different places. It's going to consume the team name and then also whatever this record is to spit out the likelihood of that being the final record for the highlighted team. Okay, so we want to make sure it's active. We'll give it a brief description. Terms, the likelihood of a team final record matching the given record. And please forgive any spelling mistakes or typos you're about to see. Like I said, we're doing this live. So before I dive into actual scripting, I guess let's first think about what it means to forecast a team's final record. What that in a sense means is that we need to start with what their current record is and then go through their remaining games and get a win probability for all of their remaining games on their schedule. Once we have those probabilities, we need to run a simulation of the rest of the season, some X amount of times. And then once we have, those simulated results, we can add those to our current record, and that'll give us our final probability. And then to get win probability, we're going to use a pretty simple comparison of just each team's points per game and points allowed per game. And I'll admit, I am no, statistician. I've pulled some references from online. So when you start seeing me like drop random, math equations, I don't want to claim that I am some wizard when it comes to stats, but the forecasting that I'm about to at least try to do is in theory pretty basic, but not, too far off from what any major sports network would do. So let's get into it. We've got some boilerplate here, which is great. We're going to, first things first is we know that this is going to consume a team name. We need to grab the record of the team based on its name. And I've actually got a script include that'll help us there. So I'm going to say const team finder equal new. Use my scoped out namespace team finder. Oh, and I already have a typo. Okay. And then we're going to say const team equals team finder dot get team by name. And this is going to consume again our team name parameter. So we're going to first check, if we have a team. We're going to do more stuff. If not, we'll just set our cell value to no team found. Okay, great. So once we have our team, let's grab our team's sys ID. And I'll invite those on the call that have much more ServiceNow scripting experience than I do to point out ways I could do certain things better. So we got our team ID, and we know that we need to get our current team's points per game and points allowed per game. We're also going to need to grab that information from our future opponents. And so I'm going to actually up here create a new function just called get team stats. And it is going to take in a team ID. And what we needed to do is grab the games that a team has already played and, from those, loop through them, get the total points they've scored, points they've allowed, and then their wins and losses. And so I know I need to do a glide record. We're looking at the X, VividSheets, UK game, and I have a typo. And then I need to add a query, add an encoded query to this. So I'm actually going to come over here to the table. I want to say, give me the games where winner is not empty and team A is, we'll use Kentucky for now, or team B is Kentucky. We'll run that. I'm going to copy this query. Drop that in here using a JavaScript template literal and replace these sysids with team ID. Okay. So that's going to grab all the games a team has already played. And then I think that's all we need. So we're going to fire off this query. To save everyone a little bit of time, I'm going to paste in some code that I have here on the side, because I've had to do this similar thing other places. And so I'm going to set up a couple of basic iterators for points scored, points allowed, games won, games lost, and total games played. I'm going to loop through all the games this team has played, iterate the total games played counter. Probably don't even need that. I think I probably could just use the length of whatever this query returned. And then, iterate games won, games lost, and the points counters appropriately. So once I have all that information, I'm going to just return out games won, games lost, points scored per game. And we're going to say for that, total points scored divided by total games played, and then points allowed per game. Cool. This feels like a good first stopping point to make sure that this function is stood up correctly. So I'm going to say, if team, let's just grab our team stats. And then set our cell value to team stats dot points scored per game. So this is obviously not the final result we want, but again, just want to quickly see, is this function working so far? So let me submit that. Then also, I would see the ability to configure my variables. Weird. Okay, anyway, let's add our two variables to the specialized function. So the first one was team name. That needs to be in position 0, and it is active. We'll add that. Then we'll also say record to check position 1, because we're using, 0-based counting here. We'll say active as well. Okay. Cool. I think that's all we need to give this a first test. So let's come back into our sheet. I'm going to save here and refresh this sheet. So I grab a fresh list of specialized functions. We'll come right here and we'll say equals, scroll through our list, grab our new specialized function. I know I want this to reference cell E2. I'm going to use a locked reference. So $E, $2. That way, when I copy and paste this down below, that reference stays put. And then I'm also going to do E10. Okay, so past initial validation. Let's collect this data and see what we get.
So Kevin, one thing to just highlight there that we haven't talked about until you just did it, but as you're creating the specialized function, the parameters that you're passing those functions are a separate table that you created there. So
yeah, correct. Yeah. Okay, so like we said, for now, this was going to spit out our points per game. That matches what we have up here. So I think we're good to keep working. So this is not actually what we want. Okay, so we have our team and our team stats. We need to now figure out the remaining games on our team's schedule. And I'm gonna borrow this code up here and essentially it's the same query with an opposite condition. So paste that right down here. Let's clean that up a little bit. We'll call this a games remaining collide record. And then we just want to say is empty rather than is not empty. And I think that's all we need there. I'm going to set up an array for containing the win probabilities for each one of these remaining games. Because like we said at the top, to forecast our record, we first need to figure out how likely it is that we win each of our remaining games. So I'll say remaining win probabilities equals an empty array. Okay, so while games remaining, next, let's loop through our remaining games. And we're going to first figure out what our other team is, what our opponent is. So, the table's kind of arbitrary. Either team can be team A or team B. So we need to figure out the opponent by saying, if our team that we're checking for is team A, then our opponent is team B and vice versa. So we'll say other team field equals, we'll say with a quick ternary, if team A equals the team ID we're checking for, then we know team B is our opponent. Otherwise, team A is our opponent. Okay, that means other team would be games remaining gr.getValue other team field. Great. Now we need to grab the points per game and points allowed per game of the other team. Luckily, we already have a function set up to allow for that. So we'll say const other team stats equals get team stats of the other team. And let's see. So the first step of determining the probability of winning a game is calculating our expected point differential. And so that is the our given team's points scored per game minus the opponent's points allowed per game divided by the reverse. The other team's points scored per game minus our points allowed per game. So we're going to say const expected point differential equals team stats points scored per game minus, I'm going to pop this into full screen mode just to give us a little more room to work with. other team stats, points allowed per game, divided by, be lazy and just copy and paste that, and then reverse these. So other team stats, team stats. Okay. So once you have the expected point differential of a game, the equation to calculate the probability, I'm going to paste in here. Again, this is where I said I kind of had to use some online help. But we set this arbitrary k to 0.1, punch that into this, relatively simple looking formula, and that spits out the probability of winning a given game. So now that we have that, we're going to push that into our array. Awesome. So now we know how likely it is we win each one of our remaining games for our given team. What we now need to do is simulate those games and add the results of those simulations to our current record. That's going to be a decent chunk of code, so I'm actually going to extract that out into a separate function as well. So let's first come up here, we'll say function simulate. This is going to take in, let's think about this. Well, first it's going to take in the probabilities. That's that array we just created. Current wins, current losses, and simulations. So probabilities, the likelihood we win each one of our remaining games. Current wins and current losses is pretty self-explanatory. Then simulations is just going to be a number to represent how many times we want to run these simulations. The higher number here, the more accurate and refined your final data will be, but obviously at the expense of, extra compute. So once again, I'm going to paste in some code here. We're coming up to the top of the hour, so I want to be respectful of everyone's time. Okay, and this actually needs to be win probabilities. Okay, so we're going to set up an empty object. We're going to set up a simple for loop to run the number of times defined here in simulations. 2 basic iterators for wins and losses that start at our current wins and losses. And then for each one of our remaining games, we're going to use a simple math.random, and compare that to the probability of actually winning the game, and then iterate wins and losses appropriately. Excuse me. Our final record would be just wins and losses, and we're going to add that final record and the count to our record counts object, and then return that. So that's all, pretty mathy. Hopefully it makes sense. It's not the primary focus of, today's call, but I'm happy to expand on any of that if needed. So once we have this function set up, back down here, we can just say counts record counts equals simulate. We need to feed it remaining win probabilities, team stats dot games won, team stats dot games lost, and we're going to run this simulation 1,000 times, which should give us pretty refined data without needing to, take this whole instance down for 10 minutes. I think all that's left at that point is to just say if record counts has an entry for the record we're actually curious about, which again was our record to check argument, then we're going to say const probability. This record counts is going to be just a raw number, and we actually want to refine that a little further. by saying how many times did that number occur in our simulations. And so we'll say record counts, record to check. And we simulated this 1,000 times. And then we're going to multiply this by 100 to get, a nice percentage. Cell value equals probability. If there is not an entry for the record we're checking in this object, it means that record is impossible. And so we can just treat that as 0. Right, because a team like Vandy is starting at 3 and 0. So it would never be possible for this object to include a key of, 1 and 6. And so we just need to account for that by saying cell value equals 0. Cool. I think that's all we are gonna need. Let me tidy that up, minimize, and save this. And let's see if this works. This is not the 0 and 7 one is not going to be a great example because, like I said, it's not possible. So let's quickly copy and paste this down here to these remaining cells. Make sure that they're all importing the row correctly and have the locked reference. They do. And let's fire this off and see if it works. Yeah, I think we're good. So given Vandy's 3-0 start and their remaining opponents, the most likely single outcome of their season is being 5 and 2. The likelihood of finishing, with one of these winning records is overwhelming. So that's pretty cool. From that, simple function, again, that took me 20 minutes, 10 minutes of which was speaking and stumbling over typos. We got a pretty cool, simple forecasting model.
Yeah, Kevin, I kind of like with Clarence's, I think, just talking through maybe 1 minute on the so what.
Yeah.
As I look at this, we have customers constantly asking us about doing their own calculations, which there's a lot of calculations going on here. So you've proven that. But this also, we've had, customers ask about creating, a sheet using their own forecasting models that they may have built elsewhere. And I think you just proved, that's a possibility that they could do here. And the nice additional benefit that I think of when I see this is not only do they get the forecasting model, it's in ServiceNow at this point, but they also get this nice spreadsheet UI as the interface to interact with that. So
yeah, absolutely. Your data is all right here on platform, and you have the ability to export this out should you need to, and maintain that, sheet visual. Yeah, we're about out of time, but there's no reason I couldn't go back to my games table, provide a result for Vandy's next game, rerun this collection, get the latest forecast of their record. The work here is really front loaded, and then I think you have this super valuable tool that you can always refer back to.
Yeah, I said I wanted people to use their imagination, and that was part of the whole point of this webinar. You prove that by having Vandy at 3-0 and Florida at 0-3 right now.
Yeah, absolutely. You never know. You never know.
Yeah. Okay, so I do want to be respectful of people's time. I really appreciate you guys putting the time into those examples. I think people will be able to use their imaginations and see what the possibility is. I would say if you have follow-up questions with us, please reach out to me directly. It's just my name, Gary Ditsch at VividCharts.com. Happy to answer questions. You can also connect to us through our website. So If you have your own idea with the Vivid Sheet, again, it's a free application. This is the specialized VividFunctions is a feature that's coming out in our next release. So I would ask that you keep your eyes open for that in the notes, release notes with that. But for now, I'll let everyone go. Let these guys get back to work and let everyone else have a great day. Happy holidays.
Bye, everybody. Thank
Thanks,
you.
everyone. Yep.